We're in this age, it's just amazing, right? AI can create these incredible, perfect videos from just a few words. It's like something out of science fiction. But here's the crazy part. What if I told you that same super smart AI couldn't figure out how to push a block across a table? Yeah, seriously. Today, we're diving into this huge paradox, this hidden and kind of surprising physical flaw in AI.
All right, so what is this hidden flaw we're talking about? Well, it's this really fundamental gap in how so many of today's most powerful AIs actually, understand the world.
And this is where it gets really interesting. It's the contrast. See, AIs are amazing at being passive observers. They can binge watch a million videos and predict the very next frame with, scary accuracy. But the second you ask one to do something, to actually intervene, to take an action and get what's going to happen next, the whole thing just falls apart. The illusion just shatters. They have this deep, fundamental struggle with separating cause from effect.
This quote from the research paper, it just nails it. Think about it like this. Just because your weather app can predict rain tomorrow doesn't mean it actually understands meteorology, right? Well, it's the exact same thing for AI. Predicting a few pixels in a video is worlds away from actually understanding physics. The key difference, the real heart of the problem, is watching versus doing.
Okay, so why? Why does this happen? The problem, it turns out, is buried deep inside their digital brains. It's what we can basically call a completely tangled understanding of reality.
You see, most of these big AI models learn by just squishing everything they see into this one giant compressed thing, a vector. The best way to picture it is like a huge tangled ball of yarn. And in that one messy ball, you've got the yarn for a block, the yarn for a table, and even the yarn for the laws of physics, all hopelessly knotted together. So what happens when you try to pull on just one single thread? Like, you just want to move the block. Well, you end up yanking the entire mess along for the ride.
And that is the big consequence of this tangled up mess. Because the AI literally can't separate what things are from how things work, it can't do any real what-if thinking. It can't just stop and ask, what if I tried this instead? Nope. All it can do is make a guess based on old patterns it's seen before, which, as you can imagine, leads to some really bizarre, totally nonsensical results.
So the million-dollar question, how do we fix this? Well, this is where it gets cool. The researchers behind this paper, they turned to a source you probably wouldn't expect for their big breakthrough, philosophy.
And here it is, the big aha moment. The idea is so simple, it's brilliant. It's something that's totally fundamental to how we reason, but for AI, it's completely revolutionary. Instead of that one tangled ball of yarn, what if you gave the AI two different, separate boxes? In box number 1, you put all the things in the world, and in box number 2, you put all the rules for how those things can change and interact.
And that simple idea, that's the core principle behind this new model they built. They call it ontological causal separation. Ontology is just a fancy word for the what, a nice, neat structured list of all the objects and what they're like. Causality is the how, a totally separate rulebook for what happens when you do something. And by pulling them apart, the AI can finally reason about its own actions. It can mentally change one little thing without completely destroying its entire picture of the world. So this new model, which is called LYGWM, by the way, is built on 3 really smart philosophical ideas. First up, causal dynamics. It has a special part of its brain just for cause and effect. Second, teleological reasoning. This means it treats a goal, like pick up the block, as an actual thing it needs to work towards. And third, and this is my favorite, dialectical novelty. It actively looks for surprises. Moments where what it thought would happen doesn't match up with reality. And those surprises, those little contradictions, they become this powerful signal telling it, hey, you need to learn something new here.
Okay, that all sounds fantastic on paper, right? But the real question is, does it actually work? Let's put this model on trial and see what the data says. All right, check this out. This table shows what happens when you ask different AIs to predict something 32 steps into the future. All you need to know here is that a lower error number is way better. Now, some of the old models do okay, but look at that GNN one. It just completely falls apart. Its error rate goes through the roof. But our new model, LYGWM, it stays incredibly stable, super accurate. That structured way of thinking actually stops it from just drifting off into total nonsense.
And here's why that stability is such a huge deal. The failure of those other models, it isn't just about being wrong. It's about their entire structure being flawed from the get-go.
They just don't have a built-in way to understand the specific result of a specific action. So when they try to think about a what-if scenario, the question itself is basically gibberish to their tangled-up worldview.
And this visual shows that what-if reasoning in action. So the model gets a scene and is asked, okay, what would happen if you did this instead? And look, it correctly moves only the things that would actually be affected by that new action. The rest of the scene, totally untouched. That, my friends, is real causal reasoning. It's something those tangled models they can't do it.
Now let's get back to how this model handles surprises. When it predicts a totally normal expected event, its prediction error is tiny. I mean, look at this number. It's basically nothing. Everything's going exactly according to its plan.
But when something totally unexpected happens, something that breaks its internal rulebook, that error suddenly spikes. And would you look at that jump? This new number is almost 100 times bigger. That is a massive difference.
So here's the crucial part. That error spike isn't a bug. It's a feature. It's a surprise signal. It's basically the AI's way of yelling, "Whoa, hold on! That was not supposed to happen. My understanding of the world must be wrong." And that signal, it becomes the trigger for curiosity. It's what pushes the AI to go explore and update its little rulebook.
So what's the big picture here? What does all this mean for the future? Well, this research is basically a powerful blueprint for building a fundamentally smarter, more capable kind of AI.
So yeah, why does this matter? Well, it's a huge shift. We're moving from AIs that are just passive predictors of pixels to AIs that can actively reason. This is absolutely critical if we ever want to build robots that can operate safely in our homes, in our offices, anywhere in the real world. And this is so important, when they do fail, this structured way of thinking lets us actually understand why they failed and fix it. This is the real foundation for AI that doesn't just copy what it's seen, but can genuinely plan, explore, and act with purpose.
And this final quote just drives the whole point home. Separating what is from how it changes, it isn't just some clever design choice. It's not just another architectural style you can pick or leave. The paper argues that this is a fundamental, necessary condition for any AI that needs to actually, meaningfully interact with and change the world around.
Which brings us to a really fascinating final thought to leave you with. If an AI can truly separate what things are from how they change, is it just becoming a better machine, or is it actually beginning to understand the world, well, kind of like we do?